Welcome to the channel. Today, we're exploring something that feels like science fiction but is already being built in secret labs around the world. A new kind of computer that doesn't just calculate faster, it uses the strange rules of the universe itself. These are quantum computers, and the way they work is nothing like the devices we use today. So sit back, relax, and let's take a slow, clear journey into the world of quantum thinking. To understand quantum computers, we need to start with what we already know. Your phone, your laptop, even the supercomputers in research labs, they all work using bits. A bit is a tiny switch that can be a 0 or a 1. Every video you watch, every photo you take, every game you play, is just billions and billions of these switches flipping incredibly fast. That's how classical computers think, one state at a time, step by step. Quantum computers replace those bits with qubits, and qubits don't follow normal logic. A qubit can be a 0, or a 1, or both at the same time. It sounds impossible, but this is a real phenomenon in quantum physics called superposition. Imagine holding a coin in your hand. If it's flat on the table, it's either heads or tails, that's a classical bit. But if you spin the coin, it's not heads or tails. It's something in between, a blur of possibilities. That spinning state is what a qubit feels like. It can explore multiple answers simultaneously before settling on one when measured. This ability to be in multiple states at once is the first big secret behind quantum computing. Instead of checking one possibility, then the next, a quantum computer can check many paths at the same time, like testing every route on a map instantly instead of slowly browsing them one by one. But the real magic starts when qubits talk to each other. Quantum computers don't just put qubits side by side. They link them through something called entanglement. When two qubits become entangled, they behave as if they're connected, no matter how far apart they are. Change one, and the other reacts instantly. It's not like a message being sent, it's more like they share the same existence. Einstein himself called it spooky action at a distance. To imagine this, think of two coins that always match each other. Flip one in New York and the other in Tokyo changes at the exact same moment. Quantum computers use this strange connection so qubits can share information in ways normal computers simply cannot. When hundreds of qubits become entangled, they work together like a giant quantum brain. Now, all of this sounds powerful, but building a real quantum computer is incredibly hard. Qubits are extremely fragile. A tiny vibration, a whisper of heat, or even a single photon of stray light can destroy their quantum state. That's why most quantum computers are kept inside giant metal cylinders cooled to temperatures colder than outer space, almost absolute zero. At this temperature, certain materials become superconductors, allowing qubits to exist without interference. Some systems use superconducting circuits. Others use trapped ions, individual atoms held in place by lasers. There are also approaches using photons, diamonds, and even topological particles. Every method has strengths and weaknesses. One thing is common: keeping qubits stable long enough to compute is one of the biggest challenges. When a qubit collapses and loses its quantum state, it's called decoherence. Imagine trying to keep a spinning coin spinning while the whole world shakes. That's what scientists deal with every day. So why bother? Why are companies like Google, IBM, and Microsoft pouring billions into a technology that seems so unstable? Because quantum computers can solve certain problems that would take classical computers thousands, or even millions of years. They can simulate atoms and molecules in perfect detail, which could lead to new medicines, new materials, and breakthroughs in chemistry. They can help design better batteries, optimize complex systems like global shipping routes, discover patterns in massive data sets, and create new kinds of encryption. Some problems that are practically impossible today might become solvable in seconds with quantum power. Decoherence. But don't worry, quantum computers aren't going to replace your phone or gaming PC. They're not built for everyday tasks. They're built for challenges too big, too complex, and too mathematical for regular computers. Think of them like scientific engines, machines built for solving the toughest puzzles known to humanity. Right now, we're still at the beginning. Today's quantum computers are small, sensitive, and full of errors. They can't run large programs yet. But slowly and steadily, they are improving. Just like classical computers in the 1960s, quantum computers today are early prototypes. In the next 10 to 20 years, they might help us unlock mysteries in medicine, physics, climate science, and beyond. Quantum computers aren't just faster machines. They represent a completely new way of thinking, a way that uses the deepest laws of nature to compute. And even though we're only at the first chapter, the future possibilities are enormous, maybe even revolutionary. Thanks for watching. If you enjoyed this calm, simple explanation and want more videos like this, don't forget to like the video, subscribe to the channel, and stay curious. Because the future of computing is only getting stranger and more exciting.